Hi everyone. So yesterday I watched a ton of mastery tests come through and scores were kind of low. And when I looked at the results, a lot of us were answering the simplifying ratios part of the problems incorrectly. So I wanted to make sure I went back through this slide with you. It was slide 14 and go through a few examples of the 3 steps that they use to simplify ratios. So in our example on slide 14 through your tutorial, we've seen that we have a ratio here of dolls to toy cars. And when we look at dolls to toy cars, there are 12 dolls to 16 toy cars. So we can write the ratio 12 to using the colon 16, or we can write it as a fraction 12 over 16. Now, with this ratio, we can simplify it, which means make the numbers go down so that they cannot simplify any farther. And when we simplify, there's 3 steps that we can take. So first, we can write the numerator and denominator as products of factors. So if you look at 12 here, 12 became 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. 16 became product of a factor by 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Now these are broken down by prime factorization. And so if you remember, you should have worked with factor trees and prime numbers. And this is the part that I want to remind you of, because you need to be able to do this so that way you can find those common factors, which is step 2, cancel out those common factors and write down what's remaining. So let's go ahead and let's take a look at what factors are. So reminding you, prime numbers, and this might be a good place. So I told you that it would be very important that you have a notebook that's dedicated to math. You need to write down your work. Just because the assignment is on the computer doesn't mean that you don't have to write down your work. So make sure you grab yourself a notebook. I would put on the front of the cover math so that everything goes inside. And that way when I give you extra resources like this, you can take notes inside your notebook. And you can use your guided notes that you took on the computer as well as your notebook to help you through your mastery tests. So prime numbers are numbers that only have factors of 1 and itself. Okay? So when we look at prime numbers, for example, if we have the number 2, 2 only has factors of 1 times 2. There's nothing else that we can multiply together with whole numbers that would make the product of 2. So then we can continue going through the list. 3. 3 again, the only 2 factors that create 3 is 1 times 3. Nothing else. So then we keep going in our list. My next number would be 4. Think of 4. There's 1 times 4. But then there's also 2 times 2. Because there's another option for multiplying that makes 4, 4 is not a prime number. So that would not work. So as we go through our list, next number would be 5. 5 is a prime number because the only 2 factors that make 5 are 1 times 5. 6. When we think about 6, there's 1 times 6, but there's also 2 times 3. So because there's another option of making 6, 6 is not a prime number. It is a composite number. Then we can continue. 7 is a prime number because it's only 1 times 7. 8. 1 times 8, 2 times 4. Because there's another option, it is not a prime number. 9. 1 times 9, 3 times 3. There's another option, not a prime number. 10, we have 1 times 10, but we also have 2 times 5. Not a prime number. 11. 11 is a prime number because the only way to make 11 is 1 times 11. Then we have 12, and we have 1 times 12, 2 times 6, 3 times 4. More options, not a prime number. So 13 is a prime number because it's only 1 times 13. 14, not a prime number. 15, not a prime number. 16, not a prime number. And then we have 17. Now there are more prime numbers, but these are the most common that you will see in your work. So you're going to want to write these prime numbers down. 2, 3, 5, 7, 11, 13, and 17. So these are what we're going to use to break apart numbers when we want to simplify. Moving forward, let's go ahead and take a look at how they got that prime factorization of 12 and 16 here of 2 times 2 times 3 and 2 times 2 times 2 times 2. So we're going to go over here. Let me find my writing tool. All right, so if we have 12 over 16, this is our ratio. We need to take each of our numbers to the side, and we are going to break it apart by giving them 2 branches. So I have 2 branches for 12, and we need to think of the ways we can make 12 with multiplication, but we can't use 1. So we had 2 times 6. So when I look at my 2 numbers that I wrote down, I need to think to myself, are either of those a prime number? Well, 2 is a prime number. So when I go back here, I can go ahead and box this because I can't break that apart anymore. But when I go back and look at my list of prime numbers, 6 is not listed, which means we can break apart 6 even further. So I'm going to give it 2 branches. Consider the 2 or the ways that you can make 6, and you can't use 1. So we have 2 times 3. Well, 2 is a prime number, so we can box that one. But when I go back and look, 3 is also a prime number, so I can go ahead and box this one, which means I have my prime factorization of 12. So my prime factorization of 12 is 2, so when I cross it off when I write it, times, because this is all multiplication, 2 times 3. That is how they received those numbers. So now we can do the same thing using 16. So I'm going to move my video so I can keep writing. All right, so let's go ahead and look at 16. 16 can also break apart, and there's different options. You could use 2 times 8, or you could use 4 times 4. I suggest that if you ever find that there's a prime number involved, use that fact because that's less of the breaking down you have to do. So 2 I know is a prime number. I've already boxed them over here. So I have 2 times 8, and I can go ahead and box my 2 because I know I'm done with that. It's a prime number. But 8 I can break apart more. I have 2 times 4. 2 is prime, I'm going to box it. 4 is not prime, so I can break it apart even further. So now I have 2 times 2, which again, I already know 2 is a prime number, so I can box them both. And now I can go over here and rewrite 16 as its prime factorization. So again, so I don't write too many, I like to cross them out as I write them so I don't leave anything behind. And that is how, in your tutorial, they changed 12 to 2 times 2 times 3, and they changed 16 to 2 times 2 times 2 times 2. Now, when we go back to our tutorial, it said step 2, we need to identify the common factors in the numerator and the denominator. So when I go back over here, I need to see what they have in common. Anything they share in common, I want to cancel out. So I notice I have a 2 and a 2 right here, so I'm going to take and cancel them out. They're gone. I have another 2 and 2 on top, so again I can cancel out. They're gone. But I'm only left with 2's on the bottom and a 3 on top. These are not common, they're not the same. I can't cancel out anymore, which leads us to our last step. It says to take what you have remaining and put them on top of each other. So 3 is the only thing left on top, so I have 3. 2 times 2 is the only thing I have left on bottom, and 2 times 2 is 4. So 12/16 in simplest form is 3/4. All right, let's try one more so you can see the breaking apart. Let's go ahead and say we have 24/60ths. And let's go ahead and use our factor trees to rewrite this as prime factorization. So let's start with 24. 24 can be broken apart many ways. We have 2 times 12, we have 3 times 8, we have 4 times 6. We can use any of those options, but I said if there's a prime number involved, use that because that's less breaking down you have to do. So I already remembered 2 is prime. I won't have to break that, and it's 2 times 12. So now 12 is not prime, I can break it apart further. 12 is 2 times 6 or 3 times 4. Again, I already know my 2 is prime, so I'm going to use that one so I can break it apart, or box it, because I don't have to break it apart, and now I can break apart my 6. And 6 is 2 times 3, 2 is prime, and 3 is prime. So now I can come over here and I can rewrite it as its prime factorization. Again, I cross out as I write. 2 times another 2 times another 2, and then times 3. All right, let's go ahead and take a look at 60. See if I can fit it in over here. We have 60, and I can break it apart as 2 times 30. I can break it apart as 6 times 10. I can break it apart as, is that 6 times 10? 2 times 30. Let's go ahead and use 2 times 30 because I already know 2 is prime. And I can go ahead and box my 2. And let's break apart 30. 30 can be 2 times 15, 3 times 10, 6 times 5. Let's go ahead and I'm going to take 3 times 10. I know 3 is prime. Break apart 10. And 10 is 2 times 5. I know 2 is prime. Can't remember 5, so I can go back and look at my notes. Oh yes, 5 is prime, so I can go ahead and box that one as well. So now notice kind of my numbers are all out of order. That's okay. I like to try to write them in numerical order. So I'm going to write my 2's first. So 2 times, and that's why I like to cross them off so I don't leave anything out. Next in my order would come a 3, and then I have the 5. All right. Once we have our prime factorization for each of our numbers written, remember we cancel what they have in common. So I see 2's, so I can go ahead and cancel those. Another set of 2's, I can cancel those. This is a 2 and a 3. Can't cancel my 2 with the 3, but I can cancel the 3 with the 3. So I can cross them off. 2 and 5 are not the same. I cannot cancel them off. So now I can go ahead and write my simplest form. 24/60ths in simplest form, I write over what's left. 2 is left over on top, and 5 is left over on the bottom. So 24/60ths equals the same thing as 2/5. Now, if forever, or in some situations, you might cross off everything on the top and only have something left on the bottom, and that can happen. If everything gets crossed off, it does not equal a 0, because then it would take everything away. The only thing that we can multiply with this that would not change anything is 1. So if you ever cancel everything across the top and you have nothing left over, that nothing would actually be a 1 because it wouldn't change what we have or change the value of what we have. I hope this helps you as you simplify your expressions. I hope that you can use these now to help you on your mastery test. Retake that mastery test and see if you can do better.